There's a couple of examples from section 9.4. I'm going to do one. These are quadratic equations where we're solving quadratic equations using either factoring or the quadratic formula. So I'm going to do one where we can factor and one where we need to use the quadratic formula. And then we'll switch the board around and do a word problem involving quadratic equations. So number one, we are given this quadratic equation in this form. And now, remember, first of all, we need to put whatever given quadratic equation, we need to change it into this form where we have 0 on one side of the equation and everything else on the other side. So here we do not have 0 on the right-hand side. It doesn't matter what side, but we need 0 on one side of the equation. So I'm subtracting 10 from this side to get to 0. And of course, whatever I do to one side of the equation, I have to do to the other side of the equation. And now I have the quadratic in the form that I want, right? My ax squared plus bx plus c. It doesn't matter if it's x's or a's or b's, whatever letter. The a is the number in front of the squared term. The b is the number in front of the term raised to an exponent of 1. And the c is the constant term in the equation. Now, first thing you want to do is ask yourself if you can factor this equation using the trial and error method or the reverse of the FOIL method, right? So if you can factor it into the product of two binomials, right? Remember, when you're multiplying two binomials, if you multiply this by this, you use the FOIL method, right? The first terms and then the outside terms, and then the product of the inside terms, and then the product of the last terms, the FOIL method. So we want to get from here to here. So we do the reverse of the FOIL. We say, what do we have to put here and here on the first terms, first times first, to get this? Well, there's only one choice, right? Here, r squared, the only choice you have is r and r. And there's a video on this separately that I posted on Canvas by some other guy who explains it very nicely how to do this factoring method. But first term times first term, no choice. Now we need factors of the c term. We need this times this to equal this number. But we also need the sum of the outside product plus the inside product to equal this term. So this is where the trial and error part comes in. You look at factors of 10. And you say, okay, well, factors of 10 are 10 and 1 or 5 times 2. 10 and 1 I can't get a 3 out of, but 5 and 2 I can, right? 5 and 2 I can get a 3 out of. I want it to be -3. So I have to be careful about where I put the signs, right? I need the product of 2r and 5r somehow to equal -3r. So that's why I'm putting the negative on the 5 and the positive on the 2, so that the outside terms give me 2r, and the inside term product gives me -5r. And when I add those together, I get my -3r. And the product of the last terms, -5 times +2, gives me that -10. All right, so once I've factored it, all I got to do now is set this factor equal to 0 and solve, and set this factor equal to 0 and solve. And I'm done. I have my two answers. I can check these, put 5 back into the original equation. 25 minus 15 does equal 10. And you put -2 back in. -2 squared is 4. 4 minus a -6. So 4 minus a -6 is 4 plus 6. That also equals 10. So we know that those answers are correct. Now you could also use the quadratic formula here, and you'll get the same answers once you put the equation into this form. Okay, so we'll illustrate the quadratic formula here in this next example. All right, so this is number 6. And again, we're not given the equation in the form that we want. So we subtract 2 from both sides of the equation to end up with the form that we want. right? Our ax squared, again in this case w, ax squared plus bx plus c. So here our a is 1, the number in front of the squared term. Our b is 4, the number in front of the term raised to an exponent of 1. And the c is -2, the constant. Be careful with the negatives. A lot of people forget the negatives, and that will screw up your answer. Once we have the a, b, and c, now we're just plugging into the quadratic form, right? And quadratic formula says that unknown variable is going to equal -b plus and minus b squared minus 4ac, all of that over 2a. And then we just carefully calculate that value, right? We got the -4 still. 4 squared is 16. Be careful here again, we're subtracting this entire product. This product is -8. So you're subtracting a -8, which becomes a +8. And we're putting all of that over 2. Just combining the 16 and the 8 into 24, we end up with this. Now we want to simplify radicals whenever we can. So let's move over here to show how we do that. Get some glaring light off of there. But whenever we have the square root of a number, we know, hopefully, from our previous classes, that if we have the square root of a product, we can write that as the product of those individual square roots of each factor. And that's what I'm doing here. And I want to pull out, if I can, a factor that's a perfect square. So I think of 24, 12 times 2, neither of those are perfect squares. 8 times 3, neither of those are perfect squares. But 4 times 6, 4 is a perfect square. So using this idea, I can rewrite this as this, and then split those up into 2 square roots. And the reason I do that, again, is because the square root of 4 is 2. So I can rewrite the square root of 24 as 2 root 6. So that's what I'm doing here. Square root of 24 becomes 2 root 6. And now I'm taking this fraction and using this idea, right? Whenever I have either a sum, it could be a difference, a sum or a difference of more than one thing over the same denominator, we can break it up into separate fractions. And that's what I'm doing here. Taking the -4 and putting it over 2, and I'm taking the plus and minus 2 root 6 and putting it over 2. And one more step to my conclusion. -4 over 2 is -2. And here the 2 over the 2 cancel out, right? 2 over 2 is just the number 1. So I end up with my answer of, in this case, W equals -2 plus root 6, and W equals -2 minus root 6. That's going to be my answer. Okay. Now we couldn't factor this one. If you look at this, there's no factors of 2 that we're going to get a 4, so we had to use the quadratic formula. In this case, the quadratic formula will work at this point, but I think it's much easier if you can factor it into 2 binomials, set each of those binomials equal to 0, and get your answer that way. All right, let's look at a word problem here. This is number 30 in your book, page 546. And we have a story about an astronaut on the moon who throws a ball upward with an initial velocity of 6 meters per second. Its approximate height, h in meters after t seconds, is given by this equation. It doesn't really matter what the story is. We're just interested in what is the equation, what are we trying to find out given this quadratic equation. So here's our quadratic equation, height and time. Height in meters, time in seconds. The question is, how long after it is released will the ball be 8 meters above the surface of the moon? So h is the height above the surface. So all we're really doing, all this last sentence is saying, is set h equal to 8 and solve the equation. All right, that's all that's being done. After all those words, it comes down to this equation, and now we're just back to solving a quadratic equation. So once again, this is not in our standard form, our general form. We need a 0 on one side. This one, we'll put the 0 on the left-hand side. So we'll subtract 8 from this side. And I kind of revert. Actually, I'm going to reverse it because I don't like the negative in front of the t squared. I could subtract 8 from both sides and do it that way. But I'm going to bring everything to this side. So I'm going to add 0.8 t squared to both sides. And I'm going to subtract 6t from both sides. And then I'm going to have 0 on the right-hand side. There's my 0. I added 0.8 t squared to both sides. And I subtracted 6t from both sides. Now I have the form of the equation that I want, right? A t squared minus b t plus c. So I identify my A, my B, and my C, and I go on my merry way, plugging it in to the quadratic formula. So a negative b plus and minus the square root of b squared minus 4ac over 2a. And then it's just about paying attention to details, doing one thing at a time, breaking this down until you get your answer. So a negative 6, glare. Let's see here, it's a little better. So the negative 6 becomes positive 6. Negative 6 squared is positive 36. We're subtracting this entire product. You multiply 4 times 0.8 times 8. You're going to get this number. And 2 times a gives us 1.6. All right, so 36 minus 25.6 leaves us with 10.4 under the square root sign. So we get 6 plus and minus the square root of 10.4 over 1.6. Square root of 10.4, if you plug that into your calculator and round to 2 decimals, you're going to get 3.22. So we're going to get 2 answers here. We're going to get 6 plus 3.22 over 1.6. And we calculate that, comes out to 5.77. And 6 minus 3.22 over 1.6. Whoops. See that? 6 minus that number of 3.22, which gives us 1.74 seconds. So what's that? What does that mean? Well, get a little picture here. This is the guy on the moon. Guess I should give him a space helmet, right? Because he's on the moon. We'll give him a space helmet with a little antenna coming out. Anyway. But so if we look at time on the horizontal axis and height on the vertical axis, let's just say 8 meters is this height. He's throwing the ball up. After 1.74 seconds, it hits 8 meters, goes a little higher, and then after 5.77 seconds, it hits 8 meters again. So that's what this story is telling us, this little picture, this fine artwork that I've created there. All right, so those are quadratic equations.